Hey, welcome back to the second part of the Creature Platformer Unity tutorial. So in this tutorial I'm going to go through the actual setup and implementation of bringing in those animated characters we did in Creature into Unity and making a simple sort of platformer scene. Alright, so before we start or go and dive into the code, let's see what this platformer can do. So you play this fox character. There's no real gameplay, to be honest, but it does show you a couple of gameplay mechanics that you expect from a platformer, right? So you get all the jumping effects, for example, and you have all these really cool, interesting characters in this bizarre world that this fox lives in, right? So you can jump onto platforms, which is why it's a platformer. You can explore the world, right? So essentially it's all the mechanics, I would say the base mechanics that you expect from a platformer if you were to construct it from Creature, from a side-scrolling, basically a side-scrolling 2D platformer demo done with Creature. That's the best way I can describe it. Okay, so you have all these NPCs running around with sort of a pseudo, I wouldn't say AI, but they run around randomly in a very funny way, of course. And then there's all the bats and the crazy horse guys running around, and you can control this fox, and you can look at these giant spirit characters turning their faces at you and all that. Okay, so here that's basically the platformer demo. Okay, so let me stop it. Let's actually take a look at what's involved. Now in Unity we are using obviously the Unity runtimes for Creature, and if you haven't already, please go onto the Creature GitHub page and grab the updated Unity runtimes. Okay, now when you grab the runtimes, you should go through again the previous tutorials on how to install the runtimes, but I'll just give you a really quick run through. It's really simple. You just drop in the two folders, distro and editor, into your assets folder in Unity, and that should install the runtime. And the way to confirm that it's installed is you go to game object, you move your mouse over the creature, and you should see all the creature items, creature objects that you can add into your Unity editor. Okay, so that's really all it is. Okay, so let's go through what's involved. Okay, so I'm going to start off with the fox character. He's the most involved and he's the main character. So here is the fox character, and I have conveniently placed all the important objects of the fox character under the fox empty game object, right? So it's easy for organization purposes. Now the fox character has a game controller, a creature game controller. It has a creature renderer. It has a creature agent, and it has a creature asset. Those are the things that you need when you want to use a creature animation object, so to speak, in Unity. Now obviously there's another way to import a creature animation object into Unity. That's through the export of FBX, but of course you lose a couple of advanced features if you were to go to the FBX route, although it's also a very viable option, I want to emphasize. So you have a couple of choices when you're using Creature, which is really nice. But back to this platformer demo. Okay, so the first thing you want to do is to set up the creature asset. You go to game object, go to creature, and you add the creature asset, right? And so you immediately, I've renamed it to be fox asset because that's basically the asset. And then you want to drag in the flat data object. That's basically the gfox export character bytes file that I exported when I did an export from Creature. Now there's a couple of files that Creature exports now. It exports a JSON file, also exports a bunch of binary files. I highly recommend use the Creature flat data binary format instead of the JSON format because it loads way faster and it's much more optimized. Okay, so you do that, and then you check the use flat data asset checkbox, and this will enable this plugin to accept the flat data binary format. So once you've done that, it will automatically populate the inspector with the animation clips. So these are the animation clips that we exported from Creature, as you notice over here. This is for the fox. Okay, very simple. The next thing you want to do is to create the renderer. You go into game object, click on Creature, and then create the creature renderer. And again, I've renamed it as Fox renderer. Okay, and under this, you want to drag in your creature asset, which is the Fox asset, which is made over there, right? And then you want to drag in the Fox's atlas, image atlas, and you may assign it a shader. I just picked a sprite shader because that's the simplest and it works really well. Okay, and that's all you need to do. And of course, you want to check loop for animation because you want to make it play continuously. So once you've done that, the Fox character should appear on screen like so. And if you play it, the character will just start playing its idle animation, but not do anything, so it's not really interesting. So how do we make it come alive? Well, this is covered in the Creature Unity documentation, runtimes documentation on the, obviously, documentations page. But I'll go through with you quickly again. The way to make it come alive is we need to first create a creature game controller. Again, it's located in game object under creature, and you create a creature game controller. Okay. Now the game controller is going to point. You're going to have the creature renderer. It's going to have a creature renderer slot. You're going to point it to your Fox renderer. That's the first thing you need to do. All right. And then the next thing you need to do is you can either click build skeleton objects, in which case it will automatically populate a bunch of rigid bodies on your renderer for you, which I've done. But what it also does is it also might create a bunch of sub bodies for each individual body part of the Fox. You might not want that, so you could delete them, or you can just manually add in a rigid body collider for yourself as well. Those are all your two options. You don't have to do it the default way. You can also just manually go in and add in a rigid body, because we need to start animating this character, like sort of move it translationally, if you want to, if you know what I mean, move it across the screen. So we need a rigid body 2D object and a collider object to make it collide with the objects in Unity. Okay, so you probably need to create these two manually, or again, I'll emphasize, you can go to Fox Game Controller and click Build Skeleton Objects, in which it will do it automatically for you. But you might not want the child rigid body, so you just have to go in there and just mass select and delete them, which is very simple. Okay, once you've done that, you point the parent rigid body to the Fox renderer, because remember, the Fox renderer has a rigid body 2D and box 2D collider object created for it, right? So we need to point the game controller's parent RBD slot to the Fox renderer. Okay, so those are the two things you need to set up: the creature renderer slot and the parent rigid body. Those two slots have to be filled up, and then the last one you need to fill up is this curious thing called custom agent. What is that? Well, you notice I have something called Fox agent over here, and the way I made this is I basically created, again, an empty game object. I made a game object. I created an empty game object, and then I created a C# script called Fox agent. Now let's take a look at that script. Actually, let me load up Visual Studio, and then I'll start explaining to you what it actually does. The Fox agent is the actual AI, if you will, or the actual code, the actual logic that makes our Fox come alive. Okay, I'm going to go through this code thoroughly to make sure you understand it, and this will allow you to use Creature interactively as gameplay elements in your own games. Now, the Fox agent inherits from this class called Creature Game Agent. Okay, so essentially, if you want to instantiate some kind of AI, NPC behavior movement, or player control movement into your creature characters, you will essentially always create a new C# script, and you always inherit from Creature Game Agent. Okay, and before I go through the code, I want to say that once you've done this, you inherited from it. What you do is you go back, you create an empty game object, you drag your script into that game object as a component. See what I've done? I've dragged this Fox agent into it, so now there's a Fox agent script attached to the Fox agent empty game object, so it has a component called Fox agent, right? And you want to point the game controller to your original Fox game controller, and you want to point the custom agent of this guy to the Fox agent. Okay, it's just really just setting up, pointing to the relevant objects. You want to make sure the game controller, the Creature game controller, recognizes the custom agent, and you want to make sure your agent recognizes your game controller. Okay, you set those things up, and again, these are all documented in the Unity documentation online. So please read through those. Okay, so let me go through the Fox agent. Now, the Fox agent inherits from the Creature game agent class, as we described above, and there's a couple of variables we need to pay attention to. The first one is the move state variable, right? This will determine the movement state of the Fox. And then there's also facing right, which determines which direction it's actually pointing to. Okay, if facing right is true, then it's facing to the right, obviously. I have a couple of constants defined, integer constants defined for the Fox, and they're denoted as move state idle, move state left, move state right, and move state jump, and move state pulse jump. I'll get to move state pulse jump in a moment. You understand what it's for. But anyway, so these are the integer constants that are defined to tell us what state the move state variable of the Fox is in, basically what movement state it's in. Okay, so in the constructor, I call the base classes constructor first, of course, and then I set its move state to move state idle because the Fox is currently in the idle state. Right, now there are a couple of methods you need to override. There's the update step method you need to override, and then there is the init state method you need to override. Now let's go through the init state first. Init state is basically the public method you override when the game controller first begins the gameplay. Okay, so you do any kind of gameplay type initializations here. The first thing you do, of course, is call the base classes init state. Okay, and then I call these two interesting functions turn off other object collisions. What does it actually do? Let's go through this function first. Now, this method or function takes in a game object array, a list, an array of game objects, really, object list. And what does it do? Well, let's look at it from a high-level standpoint. First, we call turn off other object collisions. It basically says, hey, find me on the game object with the tag horseman tag. And then the next line says, do the same thing again, but find me on the game objects with the tag bat tag. So if we go to the scene again, and if I look at one of the bats, you will notice, for example, let's look at the renderer. You'll notice that the bat is tagged with a string called bat tag, right? And similarly for the horseman, each horseman is also tagged with a string called horseman tag. Yeah. So if we go back to the code again, what this line actually says is give me all the objects that are tagged with these tags, which is what we did, and then we're going to turn off the collisions between our Fox and those NPC objects. For the purposes of this demo, we don't want the NPC to be colliding with the Fox. That's why we're doing this in the init state. So let's look at this method again. What it does is it grabs the creature renderer from the game controller. So we have a handle to the creature renderer, correct? Then we grab its parent object, okay? And then we grab the self collider, or rather the collider that's attached to the creature renderer. Let's take a look at the renderer again. Let's open up the Fox. Where is he? There he is. So remember, the Fox has a box collider 2D attached to itself, right? So we're grabbing a handle to that object over there. So we grab the self collider, and then we say for each object, current object in the object list, I grab the target object's collider, the object collider, and then I go in and turn off collisions. I say ignore collisions. Turn off collisions between my Fox collider and the target collider. That's what this line does. So essentially, this method will turn off all collisions between the Fox and the NPC collider. That's what we're doing. So we call it for all the horsemen and the bats. Okay, so that's init state. Okay, so init state's done. It's easy. The next thing we're going to talk about is the update step method. That's where the meat of the function actually is. It actually does the movements. So in update step, the first thing we do is we call the base class's update step to do whatever initialization, whatever code in the base class needs to do, and then we detect for user input. Right? We need to know if the user's holding down the left key, the right key, or releasing the left key or releasing the right key, or holding down the space bar, right? So the left keys are A, the right is D, and so on and so forth. Okay, so we have the code to detect user input. Once we're done with that, we have those booleans. We say, hey, is left down? If you're down, then since you're moving left, you're not facing right. So facing right is false, and your movement state is you're moving to the left, right? And similarly for right down, we do the same thing. If you're moving to the right, your facing right boolean is true, and the movement state is move state right. Now, if you lift up either of the right keys or the left keys, then we reset the state back to idle. And if you're holding down the space bar, we transition to the move state jump. Now, crucially, or more importantly, remember we're not doing any kind of actual movement or setting up animation yet. We're just setting up the variables that are required in the functions below to actually set the movement in end animation. So let's take a look at the actual functions. There's two functions, set movement and set animation. In set movement, this is where we actually set the movement of the fox, right? So what we do is we grab the fox renderer, the creature renderer, we grab its parent object, and then we grab the parent RBD. Remember, let's go back again. In the fox renderer, we have a rigid body 2D attached to it. This is the parent RBD. So we grab it. We grab that rigid body, and then we set up some variables. We set the speed. This is the horizontal movement speed, the lateral movement 25. You can play around with it however you please, and then we grab the parent's current velocity. We're going to store that, use that for later. You'll see in a moment why. Now, if we are moving to the left, what we do is we grab the parent rigid body, and then we set its velocity to a negative speed because we're moving to the left, and we set its current velocity of y, the y component, to be the same, right? It could be falling through the air. We want to keep its current velocity. That's why we have this line over here, to get its current velocity so we can keep its y component, since we're only moving laterally. We only care about the lateral movement, horizontal movement, sorry. So we have that, and then if we're moving to the right, we do the same thing, except the speed is now a positive number, so we don't negate that, okay? So these two clauses basically determine its left and right movement. Now, if we're idle, then we just set its velocity, we set the x component to 0, right? Because we're not moving, and we keep the y component. Okay, so that's easy. So left, right, and idle. That's pretty trivial. Now for jumping, it's more complicated. Okay, so when we enter the jump state, what do? Well, we only want to be able to jump if we are in contact with the ground. It doesn't make sense if the character is in midair and you want to jump again, unless you want to do some kind of double jump. But for this case, we're just going to jump when we're in contact with the ground. Right. So we need to know if we're in contact with the ground. How do we do this? The way we do this is we call this function again, find game objects with tag ground tag. So let's take a look at the scene again. Now this is the ground, and you notice I've tagged the ground with a string called ground tag. I've also tagged the platforms, all the different platforms, with ground tags. See this? All these are all the different platforms that a fox can land on, and I've also tagged it with the tag ground tag. So when we call the function find game objects with tag ground tag, it's going to return all the ground objects as a list that we can collide with and jump from. So what we do now is we say for each ground object in ground objects, we're gonna grab its ground collider 2D, and then we're gonna ask the question, is our fox rigid body touching the current ground collider? That is, are we in contact with the ground collider? If we are in contact, then we're allowed to jump. Okay, so then we start jumping, and what we do is we have a jump force X. This is the lateral movement of the jump. There's a lot, because we don't just want to jump vertically, we also want to jump we also want to have some kind of lateral movement, right? It's going to jump horizontally as well. So we're jumping forwards, in other words. So we have a jump force X variable with a 30.0 value. You can again change it however you want. Now, if we are not facing right, that is, if we're going to the left, we want to negate this jump force X. That's why we negate it here. So this determines the lateral direction of the jump. All right, and then finally we call parent RBD add force with the jump vector. The jump vector is basically the jump force X, that's the lateral part, and then more importantly the vertical component 150. Right, this is how much it's going to jump vertically. Okay, and then the second argument, we're going to call it with the impulse. the force mode to the impulse. And we want an impulse mode because we want an instantaneous change in velocity. We don't want it to have some kind of lag or delay, and hence we're using the force mode to the impulse mode. So this statement will allow our fox to jump immediately, and then we break from the loop because we're done. Okay, and once we break from the loop, crucially we have to set the move state to move state post jump. We're transitioning to post jump because we're done with jumping, if that makes any sense. Let's look at what the post jump actually does. So in post jump, we're done with jumping. We want to know when we're going to land on the ground again. Once we land on the ground, we want to transition back to the idle state. That's what post jump is. We're in the air, we want to land, and we want to know, we want to transition back to idle. So in post jump, we're going to see if we're going to be colliding, if we're colliding with anybody. There's a boolean on Creature Renderer called isColliding, which allows us to know if we're colliding with anybody. And if we're colliding with anybody, we set it back to idle. You don't have to do it this way. Of course, you can do it the old way, which is also just grab all the ground objects and loop through them. Okay, and then if you're touching, then you again set it to idle and break. Those two methods work. This is just for simplicity. Okay, but anyway, so once we're done with post jump and we're colliding, we're back to the ground, we set it back to idle, and we are done. So that concludes the set movement method. Now, with set movement done, the next thing we're going to do is we're going to set the animation of the fox. We haven't set the animation, of course, right? So we're going to set the animation of the fox. So in set animation, same thing. We're going to grab the renderer, okay? And then, if we are facing right, if the fox is facing to the right, we set its scale to this factor over here. The crucial thing to note is we are negating the x component because we are facing to the right, and initially our character is facing to the left, so we negate it. That's all. But we want to face the right direction. Now, if we are not facing right, we're facing left, then we just leave it as the default vector, where all the components are positive. Okay, very simple. Now, once that is done, we set the actual animation. If we are moving, that is, if our move state is right, our move state is left, we blend smoothly. We call creature renderer.blend to animation. We smoothly blend to the run cycle. All right. Now, if we're in the jump or post jump mode, we should play the jump animation, correct? So we call blend to animation jump. And finally, if we are in move state idle, then first thing we're going to do is we finish the jump, right? So we reset the jump animation. We want to reset it back to the start time, and then we blend back to the idle animation, right? So this entire bunch of if statements basically sets the correct direction the character is pointing, and also the correct cycle it is trying to blend into, right? Okay. So once we're done with that, let's play the game and see what we have. So here's our fox. See, I'm moving to the left, I'm moving to the right. You can see how the different movements are playing out pretty nicely. I can jump, right? I jump on the platform. I can jump over the character. It's pretty cool, right? And you see all the contacts are working, so it transitions smoothly to the correct phase that we want. And that's all the game agent. That's what the game agent is doing right now. It's helping us select the right state for our fox character, right? Pretty cool. Okay, so that basically concludes the fox control portion of this tutorial. Okay, so now I'm going to talk about the other characters. Let's do the NPCs right now. Let's talk about the horseman NPCs, because that one's kind of interesting. So let's select the horseman render. Okay, how's that guy done? Well, the horseman NPC is done with the horseman agent, the horse agent, if you will. So let's open up the horse agent and have a look. So here is the horse agent. Now, again, it inherits the same thing from creature game agent. It's a lot simpler than a fox, so this should be a lot easier. Now, we again have a state variable, and we're going to set it to move state idle this time. Okay, and we have 3 states: idle, right, and left. All right. So the horse is either in the idle state, moving to the right, or moving to the left. We also have something called change state counter. This is really just a timer counter, a trigger, that you're going to see in a moment how it works. Okay, we set it to 0 initially, and then initially the horse is facing to the left, so facing right, the boolean is false. Right. Now again, in the init state method, I am turning off object collisions of the horse with all the horsemen and the bats. We don't want the horses to be colliding with anything else. Okay, so same thing here, just like the previous Fox agent. Now, let's talk about the update step. Let's talk about the change state counter first. Okay, so first of all, look at this line over here. This says at every update step, we're going to decrement the change state counter by 1. Right. Now, if you remember, initially it's set to 0, so this line is going to hit immediately because it's going to be less or than or equal to 0, right? So what this line says is, hey, I'm going to trigger this if clause when it's less than or equal to 0. What does it do inside? Well, when the change state counter variable is less than or equal to 0, we're going to set a positive random number for it. We're going to call random.range from 30 to 120. Again, you can change this, but this is really just like a timer countdown. It's going to give it a random countdown when it's going to 0, and then it resets it to some higher positive number, and then it proceeds to decrement it again every frame. So once it hits 0, it resets the timer, if you will, you call it a timer counter, to another positive value. And after that is reset, we then change the state. We then randomly change the state of the horse with a value from 0 to 2. So if you remember over here, we have different states, different movement states of the horse, right? It's either an idle state, moving to the right, or moving to the left. So in other words, what this function actually does is it's saying that we are going to have a timer countdown or a counter for the horse. When it hits 0, we immediately change the movement state of the horse to something random, to another random state, and that allows the horses to move left, move right, or be idle randomly. So it gives it more of like a interesting group motion, if you will, right? So this will then allow us to randomly determine state of the horse, and then we call the usual set animation and set movement functions, right? So let's take a look at set movement first. Well, in set movement, what we do is we grab the creature renderer. Again, we grab its parent object, its rigid body, same thing as the Fox. We have a speed variable, we grab its current velocity, and now it's really simple. If we're moving to the left, that is, we're in move state right. If we had set our random state to moving to the right, for example, we assign it a new vector that moves to the right, and then we move to the left, we assign another vector, same thing, except we negate the x component. That's all it is, right? So it's super simple. It just moves the horse to the left or right depending on its current state. And then in set animation, we do the same thing almost as the Fox. We grab its current renderer, right? And if we're moving to the right, we blend it to run. If we're moving to the left, again, we blend it to run because we're also moving. And if we are idle, we blend it to the default, right? And then we determine how, based on where the character or the horse is facing, we scale it. And the crucial thing to note here is the x component. If the horse is facing to the right, we negate the x component, otherwise we set it to its default value. That's all it is. So really, this is like a simplified version of the Fox agents, but way simpler because there's no user input and there's no jumping. It's just the only thing to care about is the random state setting portion here, and only sets the random state when the change state counter is 0. Okay, so let's play the game. Now you can see everything working in motion. So look at these horse guys. Look, they're all running randomly. That guy in the back is idle, and sometimes they stop, right? That's all based off the horse agent's logic. And you can see the bats. The bats are also running off the same logic. So let me find another couple of other horses, right? And this is pretty cool because you can see the game logic, the game agents in action. And hopefully this illustrates to you how easy it is to create a 2D side-scrolling platformer in Creature using the Creature Runtimes and the Creature animation tool. So hope you enjoyed this tutorial and had fun animating.